Hey everybody. Today we're talking about leverage, discrepancy, and influence in the linear regression setting. I'm going to stick to the situation where there's a single explanatory variable, but everything I say in this vid carries over directly to higher dimensions. So, in a two-variable dataset, individual observations can be unusual in their x value, the y value, or both. When we use the word outlier, we're referring specifically to ones that are unusual in the sense that they vary substantially in the y direction from what would be expected given the general trend of the data. In other words, they're points that have high discrepancy. Now, of course, in practice, just in our everyday lives, we use the word outlier more loosely than this. Here's a picture illustrating what I mean. Here are three data sets, each with a linear trend, and one unusual observation. In the first two graphs, you see that the point lies far from the regression line. It has high discrepancy. In the third case, the unusual value is more or less in line with the trend of the data, so it's not really being considered an outlier here. Observations with unusual x values have greater potential to affect the fit of a model, and such observations are said to have high leverage. So leverage really here is a concept that refers only to the explanatory value of an observation. Let's look at those same three plots again, this time from the perspective of leverage. In this case, the two plots on the right show observations with high leverage. The unusual value lies far away in the x direction from most of the data. The first plot shows an outlier with low leverage. Although it is an outlier, its x value, its explanatory variable's value, is very much in line with the other values in the data set. An observation that substantially changes the fit of a model is said to have high influence. So let's look at those two outliers from the first plots, again, from the perspective of influence. In the first graph, we see an outlier that has low influence. If we remove this value from the data set, the regression line does not shift substantially. In particular, notice that its slope in this case stays more or less unchanged. In the plot on the right, we see an outlier that has high influence. If we remove it from the data set, the regression line does change substantially. Typically, in order for an observation to be influential, it has to have high discrepancy and high leverage. Now, of course, all of this can be quantified, and I'm not going to go into this in detail in this vid, but I at least want to nod in the direction of where this goes if you pursue this idea further. Discrepancy is usually measured using studentized residuals, so these are just sort of standardized residuals that measure how much the observations differ in the y direction from the model's prediction. Leverage can be measured using hat values. So this is a measure of how far off the values are in the x direction from what you would expect, from what the average x value is. And finally, influence is often measured using Cook's distance. Now, none of these are fun to compute by hand, and so of course you shouldn't do it. R is really the best way to go about it. In particular, you tend to get outputs like this if you use the Broom package. So there'll be a video on that as soon as I can get around to it.